Hello friends and welcome to average classes. Okay, so the today's topic is gonna be very interesting. Surface tension is one of the very interesting, the beautiful subject of your fluid mechanics. Okay, and you'll come to know by in some time. So we'll start surface tension. Then sir, what is surface tension? See, surface tension is a property. Okay, property का मतलब क्या होता है? See, like human beings, you have eyes. Every eye of a human being is different. So similarly, the surface tension of every liquid is different. Actually, you can identify the liquid by its surface tension, provided it is not being altered. Like its temperature is not altered. Okay. So what surface tension says? It's the property by which a liquid tries to minimize its surface area. Okay. Minimize. It will try to minimize its surface area. Sir, what's meant by minimize? Minimize मतलब क्या? It tries to occupy as less surface area as possible. It will try to minimize the surface area. Means it will try to occupy very less surface area. How? It will try to pull the cohesive forces which is acting on the surface. They will try to pull the other molecules and they will try to shrink. They will try to minimize. They will try to occupy as less area as possible. That's why we say it's the property by which a liquid tends to minimize its surface area. Okay sir, आपने बोल दिया whether it is true or false. See, there are so many examples in your nature. If you see, what is the drop of liquid? What is the drop of a rain liquid? A small liquid drop. What do you find? Sir, it is spherical in nature. Now why? Why it is spherical in nature? Take any given volume. Take a given volume. Okay, probably small shape. Okay, take any given volume. So which geometrical shape gives me minimum surface area? Which geometrical figure gives me the minimum surface area? Which one? Spherical. Which one? Spherical. So that's why you'll find the liquid drops are what? The liquid drops are spherical in nature. Okay. Okay, sir, but we have seen some liquid drop, they will become little flatter. Why is that? See, why is that? It's also a very interesting thing. So you have a liquid drop. Okay? आपका liquid drop spherical. The mass is little small. थोड़ा mass लिया है. Now try to take a bigger mass. What happens when you take a bigger mass? Sir, it becomes under. Exactly. It's not much spherical anymore. Tries to take little more. What happens? It becomes a little like, isn't it? It becomes more and more flatter as the size increases. See the beauty. Come on. It becomes more and more flatter as the size increases. Now why is that? Why does that happen? So why that happens is, see, so as the size increases, this implies what happens? So the gravitational force acting on the liquid drops will increase. As the gravitational force acting on them increase, the shape adjusts. Adjust in such a way that क्या होता है आपका? The sum of which two energy? Sir, gravitational potential energy, fantastic, and the surface potential energy becomes minimum. Or you can say, as the size increases, the gravitational potential force or the gravitational force which is acting on them increases. Because of that, the shape adjusts to the minimum sum of gravitational potential energy and surface potential energy. So what happens? Your center of gravity becomes as low as possible. तो आपका center of gravity क्या होता है? नीचे आ जाता है. Center of gravity tries to be as low as possible. Hence your liquid drop becomes flattens. Hence, as the size increases, your liquid drop becomes flattened. But if you take a small size, yes, what happens? They are spherical in nature. Why they are spherical in nature? Because for any given volume, the minimum surface area is which geometric? Spherical. The minimum surface area is for a minimum geometrical shape is a sphere itself. So that's why your liquid drops are spherical in nature. Okay, so this you understood. Sir, is there any proof? Like, can you do something else to prove it? Yeah, note it down. Note कर लिया? Pause करके note कर. Okay, so now what we can do is we'll try an experiment, a small experiment, interesting one. ठीक है? You can try this in your home if possible. देखो. Now what I'll do is, okay, take a ring. क्या लोगे आप? सर हम एक रिंग लेंगे. ठीक है? हाँ? Take a ring. I'm not doing this anymore. Now dip this ring in soap solution. Where you are dipping this ring? In the soap solution. Dip this ring in the soap solution. आपने ये रिंग लिया, रिंग को ऐसे सोप सॉल्यूशन में डिप कर दिया. ठीक है? Now take the ring out. Take the ring out of the soap solution. What you'll find, sir? Ring में there will be soap film. What will be there? Sir, ring will be having some soap film. Some soap film. Now don't say you are not understanding this problem. बचपन में you must have done this. You can see this, right? आप क्या करते हो? इसको ऐसे निकालते थे as a kid and you will be doing. So what happens? See, this is a ring which is empty. Can you see? Empty. Now I have dipped inside the soap solution. ठीक है? When I take it out, what is there? Can you see? There are some bubbles. There is a thin soap film here. Can you see? It will be difficult, but you can try. You must have tried this. There is a very thin soap film over here. Okay? फिर आप bubble form करते थे. Okay, that's not this. See, it's spherical in nature. Bubble. देख लिया? Proved. So soap film. Now you understood, right? There is a soap film. Now what we'll do is we will put a looped thread. क्या डालेंगे? Looped thread. मतलब क्या सर? Closed thread. मतलब क्या? Closed thread. एक closed thread. Very, less weight, so that the film can hold. Otherwise, you have to take a larger film so that you can have little more mass of closed thread. Okay. Now, what you'll do is, I'll ask you to touch up. क्या करो? Poke it. Okay, poke it, break it in the middle. This area you just break it. What you'll observe? That's the interesting thing. What you'll observe is this closed thread now, which was irregular in shape, it will become circular in shape. So क्या हुआ? What happened when you have poked or disturbed or burst this area? The thread stretched radially. The thread stretched radially. क्या? Outward. The thread stretched radially outward. Now this is interesting. Why did this happen? Okay. So हमने क्या पढ़ा? Surface tension में what we studied in the surface tension? So it tries to minimize its cross-sectional and minimize its surface area. The cohesive forces or the cohesive forces between the same molecules will try to stretch it, okay, towards them, so that they will reduce the surface area. They will try to as less surface area as possible. ठीक है? It will try to occupy as less surface area as possible. वो पढ़ा था हमने. ठीक है? So now they see what happened before. These outer liquids or outer molecules, they were stretching it. They were pulling it toward them. ठीक है? Now inside also, the liquid present inside also, that also pulling them with the same force towards them. ठीक है? These molecules, the cohesive forces between these molecules will be pulling the thread towards inside. Similarly, the outside fluid will be trying to pull the thread towards them. आप खेलते हो ना? Tug of war. Like that they are doing. But because here also surface tension, here also surface tension. So what happens to the F net here? The F net becomes zero. That's why the thread does not change its shape and size, because it is in equilibrium. Interesting, isn't it? But now what you have done, you have poked the inside area. What you have done? You have poked the inside area. Because you have burst the inside area, there is no molecules are present to stretch it inside. So the only force which is acting here is outward. That is the surface tension. The surface tension pulls it towards them. The surface tension pulls it towards them. This molecule will try to pull this. This molecule will try to pull this one. This molecule will try to pull here. So similarly, from all sides, these molecules by their cohesive forces, they will pull it towards them. Why? To minimize the surface area. To minimize the surface area. Okay, sir. Then why it is in circular shape? Remember this. One more interesting geometry. For a given perimeter. For a given perimeter. For a given perimeter, circle is having the largest area. For a given perimeter, which geometrical figure is having the largest area? Circle is having the largest area. So this area increased. Because this area increased, what happens to the area outside? They become less. It decreased. Hence, where the liquid are present? The liquid are present in the outer area. This area increase, this empty or void increase. That's why the occupied part becomes less. This proves that, this experiment proves that liquid has surface tension, which tries to minimize its surface area. Understood? Okay. Interesting, isn't it? Interesting, isn't it? Okay. So it tries to minimize its surface area. Okay? Dekha? Correct. Sir, one more, please. Note it down. Those who want to note it down fast. Pause the video and note it down. Okay? So, we have took a ring. The ring we have doped into the soap solution. Then we took it out. When we took it out, the ring has formed a soap film, and we have kept a closed thread here. Then we burst the closed thread. After that, we found there is a circular section. That means the surface area has been reduced by the water molecule because of the cohesive forces, and they try to occupy as less area as possible. Okay. So now we'll go for one more. Experiment. Now I have a U fill. क्या है मेरे पास? I have a U, not a fill. I have a U frame. I have a U frame like this. देखा? क्या है मेरे पास? U frame है. Now I have a slider here. What I have? A slider. I have a slider, and this is a U frame. That means what? This slider can move left, right, zumba, zoom. Okay, this can move left, right. Okay, this I have kept in, the slider I have kept in vertical position. Now I have a U frame like this, a vertical U frame, and this time the slider is horizontal. Now the slider is horizontal, means it can move up and down. But what I have done is, I have applied a small weight here. मैंने एक small weight यहाँ पर add कर लिया. So what you can suggest from here? Sir, if you are restricting the movement here, then the slider may bend, or the mass is so less that it just can only make a little bend. ठीक है ना? Now what I have done is, again I have dipped both this U frame in the soap solution. With the slider I have dipped inside the soap solution. Once I have dipped in the soap solution and I took it out. Once I took it out, what I will find? Again I will find a soap film. So what will happen in the first case is, now this is your soap film. What is this? Your soap film. Again, these are very small masses. Understood? These are the soap film. Now this soap films, what they will do? They will try to minimize the surface area. That means the cohesive forces are then will pull them. So that's why before the slider was moving both the sides, but now the slider move towards the end. Which end? Left hand. So the slider now will move towards the left hand. Again, this proves what? This experiment proves what? The surface tension phenomena of the fluids. Isn't it interesting? Okay, but sir, what will happen to the other case? What will happen to this one? Now see, I have told you I have used a very small mass. I have not used a big mass. Okay, I have used a very small mass. So now, how we have used the mass? I have used the mass in such a way that the force, the surface tension, surface tension will balance this mass. This will balance this mass, and it will be in rest position. It won't be again bend anymore. Isn't it? Normally you should have thought it should have come down because we have added some mass, so we thought it should have come down. But instead of coming down, what happened? It became balanced because of the surface tension. The fluids, they will try to pull this molecule will try to pull this. Okay, this molecule will try to pull this. This molecule will try to pull this. So they will try to pull, stretch it. You are getting my point. They will try to minimize the surface area as minimum as possible. Isn't it interesting? Isn't it? Okay. So next what we will do? Okay, pause the video and note it down. Okay. So next what we will do is, I told you this is a beautiful concept, surface tension, and we are not done yet. We have to teach a lot of other stuff also in surface tension. Just the beginning. Okay, just the beginning. So now what we'll do is, we will take a needle. ठीक है ना, a greased needle made up of steel. We'll take that. क्या होगा? सर डेंसिटी ज्यादा है, वो गिर जाएगा. What if I'll tell you कि it won't sink, whereas it will float, whereas it's gonna float. Okay, say this. Can you see this? This is water. Okay, a glass is having water, and glass is having water. Is it visible now? Okay, the glass is water, and you see this needle is floating. Can you see here? This needle is floating. Okay, got it? And can you see this? Okay, that's why I took a transparent tumbler. So now you can see this. The pin here is floating, whether it's having high density. So the pin is not, sink. It's not sinking. It's floating. Same. What's the phenomena here? Surface. Surface is having some energies. Surface tension. The surface, because of the surface tension, it balances with the weight. Okay, sir, how does it do? Come on, prove it. क्या आप बोल रहे हो? हमें तो समझ में नहीं आ रहा है. Okay, see, this you can do by yourself also. Take a beaker or glasses में कुछ पानी लो, ठीक है? And you have took the needle. I have took a water. Take a blotting paper. On the blotting paper, keep your needle or keep your pin. Okay, keep your needle or keep your pin on the blotting paper. Then you slowly place it. What you have to do? Slowly you have to place it. The blotting paper it will absorb the water, it will soak the water, and it will sink. But your needle will be floating. Your needle will be floating. Now, if the front view looks like this, this is your needle. The weight is acting vertically downward. What happens to your surface tension? This is how your surface tension works. And the vertical component of the surface tension, come on. The vertical component of this force balances the weight. Vertical component of this force balances the weight. So along which direction your surface tension force is acting? Along the liquid surface. Where it is acting? Along the liquid surface, parallel to the liquid surface. Isn't it interesting? See, if I draw your surface top view, if I draw, it will be like this, right? Okay. Let us say this is your needle. Your needle. And what is the length of the needle? L. What is the length of the needle? L. And total everywhere you have liquid. Okay. So imagine this is your length. Okay. And what these forces will be trying, the left hand sided liquid, they will try to pull it towards them, isn't it? These actually पूरा surface में तुम्हारा surface tension लग रहा है. ठीक है. Just to make you understand, here I told the vertical force has been balanced with the weight. So the horizontal forces, the force is acting towards this. Okay? This forces, the right hand side forces are pulling it towards them. ये मॉलिक्यूल इसे पुल कर रहा है, ये मॉलिक्यूल इसे पुल कर रहा है, ये मॉलिक्यूल इसे पुल कर रहा है, लाइक दैट, you know, these are pulling each other. But actually entire surface mein your surface tension is acting. Actually the surface tension is acting on the entire surface itself. Okay, so this force, where, how it is acting? Sir, it is acting along, it is acting along the liquid surface. Okay, and it is also perpendicular to the needle, the line of what I have drawn. The line of length L what I have drawn, the forces are perpendicular to that and along the surface. Correct. So to quantify or to give you the magnitude of this force, what is the magnitude of the surface tension? We use this. Hence the surface tension, you write sigma or you write S or you write T, whatever you like. We will follow with sigma. So the sigma is equal to F divided by L, length. F divided by L, length. Remember, if you have a liquid surface of this, like, you know, a circle, so entire surface, on this, the surface, you know, tension is acting. So here L is equal to your pi into D, 2 pi r. L will be the 2 pi r. Entire circumference में लग रहा है your surface tension. Okay, that will study in calculator after some time. So sigma equal to what? Your F by L. That is, surface tension equal to force per unit length, force unit Newton liter, length unit meter, Newton per meter. What is the unit of surface tension? Newton per meter. What is the unit of surface tension? Newton per meter. Now we'll write it. Dimension. Newton means what? Sir, kg meter per second square. Meter cut T. So remaining what? Your kg per second square. So what is the unit? M T minus 2. So many times in exam they directly ask what is the unit and dimension of surface tension. What is the dimension of surface tension? M T minus 2. What is the unit? Newton per meter. That is the surface tension. The magnitude of this force, or to quantify this force, is nothing but the force per unit length. Force per unit length. Tell me you understood. Okay. What is sigma? Sigma equal to, sir, F by L, Newton per meter. Okay, so what is surface tension? Sir, it is the property by virtue of which the liquid tries to minimize its surface area, tries to occupy as less area as possible. Okay, okay. Which area? Surface area. So where it acts? Around the surface. So is the surface property of a liquid is different from the bulk property, inside property? Definitely yes. Definitely yes. The surface area of the liquid, the surface properties are entirely different from the bulk properties. Okay, and we are here only studying the surface property. Okay. Okay. So yes, pause the video, note it down. Note कर लिया? Okay. So now अच्छा, आपने देखा होगा when you are सुबह उठ के ब्रश करते हो, कौन गंदा आदमी ब्रश नहीं करता? करते हो, right? Everyone brush, right? Yeah. So before you are brushing, what you do? आप उसको पानी में डालते हो. What happens when you pour some water into this? You'll find the disordered or disorganized, okay, brush will become organized. Correct? More and more, well organized, and so that they will be closer to each other. Again, why? Surface tension of the liquid tries to pull it. Very good example. You water लगाते हो hair में, या फिर you apply oil, what happens? चिपक जाते हैं. Okay, that's a different thing, चिपकना. But when you pour water and all, what happens? They come closer to each other. Why? Because of the surface tension. Surface tension क्या होता है सर? उनके अंदर क्या है? कोई सी forces are pulling them, right? Bringing closer to each other. More the surface tension value, more closer are the molecules. More closer are the molecules means more well shaped they will be. More well shaped they will be. What is the value of surface tension of water? Surface tension of water is 0.0736 Newton per meter. What is the surface tension of mercury? Sir, 0.451 Newton per meter. Whose surface tension value is more? Mercury surface tension values are more. Because mercury is having more surface tension value, that means what? Their molecules are more closer, more stronger, more cohesive force. That's why the shape of mercury you will find will be more spherical. They won't easily get flattened like water they do. If you take little larger drop of water will flat. We have already studied. But if you see mercury, Mercury will be spherical in nature only because of higher surface tension. Because of this, they have more cohesive force. They have more cohesive force. Molecules are more closer to each other. They try to pull them closer. Okay, they try to more and more be stretched and make as small area as possible. That's why they will be maintaining the spherical nature little more time rather than the water. Okay, understood. So same thing. Your painting brush. You keep the brush in your paint, emulsion or a liquid and you take it out. You'll find them quite shaped. Quite well shaped. That's what the surface tension does. Okay. So water is 0.0736 Newton per meter. Mercury is 0.451 Newton meter. What happens of soap water? Surface tension of soap water 0.03 Newton per meter. What you have observed? The surface tension of soap water is less than the surface tension of water. Yes or no? Now how this helps you in cleaning clothes? आप जब कपड़े साफ करते हो, you wash your clothes with detergent, with the soap solution. Okay, when you make the detergent solution or soap solution, ऐसे कपड़े काटते कपड़े साफ करते हो, isn't it? So when you this soap water, we use the soap water for cleaning clothes. Okay, to clean clothes, you use soap water rather than the normal water. What actually happens is your dirt, which is accumulated on the fiber of the clothes, are on the very tiny space. These spaces are very, very tiny. Here are your dirts, and normal water cannot penetrate through this. But soap water, what is the surface tension of soap water? 0.03, which is less than the surface tension of water. Because the surface tension is less, means the forces, the cohesive forces are acting them are little less. Hence, the molecules of the soap water can easily penetrate through the tiny surface of your clothes, fiber of the clothes, and will displace the dirt. Here your molecule entered, dirt displaced, and your clothes become clean. Okay, interesting, isn't it? Now, sir, sometimes we also use hot water. Correct. What happens is, when you increase the temperature, what happens to the surface tension? Sir, surface tension decreases. Because surface tension decreases, the cohesive forces become less. So the molecules are now more free to move. As they are more free to move, they will again enter in the tiny space and will displace the dirt. Tiny space of the fiber in the cloths, and they will displace the dirt. This is how your clothes become clean. See, surface tension mechanism यहाँ पर. Okay, you have been doing washing your clothes, means your mom washing your clothes from many years. This is the mechanism how it goes. Okay, this is how it cleans the dirt and all. I already told you surface tension is a very, very interesting phenomenon. Okay, it's a very, very interesting phenomenon. It's a beauty of fluid mechanics. Okay, one of the beauty of the fluid